How does yield strength prevent creep in materials? Imagine a metal part in a machine that needs to last 4 years without changing shape. How does it stay strong over time, especially under heat and stress? That's where yield strength comes into play. Yield strength is the maximum stress a material can handle without permanently bending or stretching. When you apply force below this limit, the material stretches a little but then bounces back. But if you go beyond it, the material starts to deform permanently. This point is like a boundary line that tells engineers how much load a material can take without losing its shape. Creep is a slow, steady change in shape that happens when a material is under constant stress, especially at high temperatures. Think of a metal rod in a furnace that slowly elongates over years. This happens because atoms inside the material move very gradually, causing the material to stretch or deform. If the stress is high enough, creep speeds up and can eventually cause failure. Now, here is where yield strength becomes important. If the stress applied to a material stays below its yield strength, the atoms don't move enough to cause permanent deformation. The material behaves elastically, meaning it can stretch and then return to its original shape. This prevents creep from happening because the atomic movements that cause creep are not triggered. Materials with high yield strength can withstand higher stresses without starting to deform permanently. That means they are less likely to creep over time. When designing parts that need to last a long time under heat or pressure, engineers choose materials with high yield strength. For example, turbine blades in jet engines are made from alloys with high yield strength so they don't slowly bend or crack during operation. Sometimes, materials are treated or alloyed to boost their yield strength. Heat treatments and adding certain elements can make the material's crystal structure stronger. This makes it harder for atoms or dislocations inside the material to move, which in turn reduces creep. In simple terms, yield strength acts like a safety threshold. If the stress stays below this limit, the material stays stable and resists the slow, creeping deformation. When engineers design components that face long-term stress, they make sure the operating stresses are well below the yield strength. This way, they prevent the gradual shape changes that could lead to mechanical failure or breakdown. So, in essence, yield strength keeps a material from slowly losing its shape over time. It sets the limit for how much stress the material can handle without creeping. By choosing materials with high yield strength and keeping stresses below that point, we can make sure parts stay reliable and safe, even after many years of service.